Welcome to Science 8 class. I am Junamalan Sepulveda. I will be your teacher for the day. Are you ready for the day? Let's get started. Our first lesson is all about the law of acceleration. The principles behind Newton's laws of motion are very significant in understanding the motion of objects in our universe. Their applications are all around us. Understanding these laws, therefore, help us understand why things around us move or behave the way they do. This lesson was based from the most essential learning competency for Science 8, which is investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. At the end of the lesson, you should be able to first, explain how force affects acceleration when mass is constant. Second, explain how mass affects acceleration when force is constant. Lastly, state the relationship among force, mass, and acceleration. Before we start with our lesson proper, please answer the pre-assessment. For online learning, open your Google Classroom or visit the link that will be given by your teacher. For modular learning, please get your learning module and open it on page 3 to 4. You have 6 minutes to finish the pre-test. Please answer honestly. Good luck. Now, let's check your prior knowledge in the concept of force and motion. Do you wonder why some things move and at times faster than the others? Let's try to find out. Motion is the act of moving or when an object moves from a reference point to another position. In grade 7 you were able to describe motion in terms of the following. Speed refers to how fast an object moves. Velocity, the speed of an object in a particular direction. Acceleration, the speed by which velocity changes. Displacement, the difference between the final and initial position. Scalar and vector quantities. Remember this. Scalar is a quantity that is fully described by a magnitude only. It is described by just a single number. Some examples of a scalar quantity are speed, volume, mass, and time. Speed is a scalar quantity. It tells how fast an object moves, but it does not indicate the direction of an object. Vector is a quantity that has both magnitude and a direction. Vector quantities are important in the study of motion. The direction of an object can greatly affect values computed for each quantities. Some examples of vector includes force, velocity, acceleration, and momentum. Velocity is a vector quantity which tells you how fast an object moves and to which direction it is going. What's the difference between weight and mass? Weight is the measure of how hard gravity pulls down on an object. The weight of an object can change. Weight is measured in Newton. Mass is the measure of the amount of matter an object contains. The mass of an object will never change. Mass is measured in pound or ounces. Based on the figure, the bowling ball's mass will not change based on location, but the weight of the bowling ball will be much lighter on the Moon, due to the gravity indifference. Take note. Mass is the quantity of matter a body contains, while weight is the force on a body due to gravity. Are you ready for another activity? Let's find out together. Grab your pen, answer sheets, and look into your module. Grab a ball in your house and place it on top of the table. Make sure it is not rolling or moving. Will the ball move by itself? How can you make the ball move? In what direction will it move? Let's compare figure A and B. Do forces present on the ball? In the above activity, the ball will not merely move by itself. If someone pushes the ball, it will move or it will roll across the surface of the table in the direction you push it. If you push it harder, it moves faster. Force can be described in terms of what it does. It can make object move faster, stop or change direction of motion. Hence, a force can produce a change in velocity, and causes an object to accelerate. You learned that when the velocity of a moving body changes, we describe the motion as one with acceleration. This means that a body accelerates whenever there is a change in speed, change in direction, or a change in both the speed and direction. Are you ready for another activity? Let's find out together. Grab your pen, answer sheets, and look into your module. Is there any relationship between acceleration and any unbalanced force that acts on the body? In this activity, you will investigate the effect of force on the box with constant mass and the effect of changing mass of the box on acceleration. Is there acceleration when you push the box? Why? There are two forms of force due to friction, static friction and sliding friction. When you push a heavy box, it pushes back at you with an equal and opposite force, third law, so that the harder the force of your action, the greater the force of reaction until you apply a force great enough to cause the box to begin sliding. You then notice that it requires less force to cause the box to continue to slide. In which situation the box will accelerate more? Why do you say so? How would you relate force and acceleration? To determine the effect of different masses on acceleration of an object, analyze the situation. In which situation the object accelerates more? Why do you say so? How would you relate mass and acceleration? Let's see if you answered correctly. Now, get your module and check your answer honestly.
Take a look at what happens when forces are unbalanced. Welcome to Moo Math and Science and Balanced and Unbalanced Forces. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. But how are balanced and unbalanced forces different? Balanced forces will cause no change in the speed of an object. Balanced forces acting on an object in opposite directions and in equal strength, as shown in the arrows below, do not cause a change in the speed of a moving object. Objects that are not moving will not start moving if acted on by balanced forces. Remember, forces have a magnitude and a direction. Unbalanced forces are not equal, and they cause the motion of an object to change. When two unbalanced forces are exerted in opposite directions, their combined force is equal to the difference between the two forces. The magnitude and direction of the net force affects the resulting motion. This combined force is exerted in the direction of the larger force. Let's take a look at some real-world examples. The forces acting on the red pull balls are balanced. The downward force of gravity is equal to the resistance force of the pull table. When the white ball strikes the red balls, the forces are now unbalanced and they move in the direction of the force. The forces are balanced on the weights. The downward force of gravity is equal to the resistance force of the yellow rack. The weights do not move. The weightlifter exerts an unbalanced force upward and the weights move in that direction. The forces on the tennis balls are equal. They are not moving. When the tennis balls are struck by an unbalanced force, it causes them to move. The resistance force of the car is balanced with the downward force of gravity. The car jack exerts an unbalanced force on the car upward, and the car moves in that direction. The car is at rest, and all forces are balanced. When the car that is moving strikes the car at rest, then the forces now are unbalanced, and the car moves in the direction of this force. If you'd like to know more about unbalanced or imbalanced forces, this playlist will help. And as always, thanks for watching, and Moo Math uploads a new math
Let's check your vocabulary. Inertia is the property of a body that tends to resist a change in its state of motion. Newton is the amount of force required to give a 1 kg mass an acceleration of 1 meter per second square, or 1 Newton is equals to 1 kg meter per second square. Familiarize yourself with the following relationship. Directly proportional. As one amount increases, another amount increases at the same rate. Inversely proportional. When one value decreases at the same rate that the other increases. Take note. The acceleration of an object is directly proportional to the magnitude of the net force acting on it, and is inversely proportional to its mass. There are two factors affecting acceleration. These are mass, force. Acceleration is equals to the net force over its mass. Let's try to solve the sample problem. Suppose a ball of mass 0.60 kg is hit with a force of 12 Newton. What is the acceleration? What is being asked? Required acceleration, A. Given force is equals to 12 Newton. Mass is equals to 0.60 kg. Acceleration is equals to 20 meter per second square. Are you ready for another activity? Let's find out together. Grab your pen, answer sheets, and look into your module. Now it's your turn. Try to answer the following. Sample problem number 2. Suppose a ball of mass 0.60 kg is hit with a force of 12 Newton. Its acceleration will be. Sample problem number 3. Suppose a ball double the mass 1.2 kg is hit with a force of 12 Newton. Its acceleration will be. Let's see if you answered correctly. Now, get your module and check your answer honestly. As the amount of applied force increases, the acceleration of an object also increases. Force is directly proportional to acceleration. As the mass of an object increases, the acceleration decreases. Mass is inversely proportional to acceleration. Let's try to answer the sample problem number 4. Suppose a ball of mass 0.60 kg is accelerating at 20 meter per second square. What is the amount of force exerted? The formula. Force is equals to mass times acceleration. You are asked to find the value of force. Let us identify the given values. 20 meter per second square is the value for acceleration. 0.60 kg is the value of the mass. For the solution, force is equal to 0.60 kg times 20 meter per second square. The answer is 12 kg meter per second square or 12 Newton. To compute for the mass of an object, just simply derive the following formula. Mass is equal to force over acceleration, where A is acceleration, F is force, m is mass. Sample problem number 5. What is the mass of an object which is accelerating at 20 meter per second square after 12 Newton of force was applied? We are going to compute for the mass using this formula. Substitute the given values. Given acceleration is equal to 20 meter per second square. Force is equal to 12 Newton. For the answer, the mass of an object is equal to 0.60 kilograms. We are done with solving acceleration word problems in relation to force and mass. Now let's expand your understanding. Which will hit the ground first? Did you answer correctly? According to the law of inertia, the lighter object must be the one to hit the ground first because of its lesser inertia. However, the law of acceleration states that the heavier object must be the one to hit the ground first because gravity pulls on it with more force. Therefore, the two objects will fall to the ground at the same time. How was your answer? Did you get it correctly? To further expand your understanding on acceleration in relation to gravity, remember this, the law of acceleration due to gravity. Gravity acts on all objects on the Earth's surface and causes them to accelerate when released. Acceleration is the same for all objects on Earth and is equal to 9.8 meter per second square.
Brilliant. Isaac Newton would say that the ball and the feather fall because there's a force
To sum up our discussion for today, the concepts are as follows. When force is constant, if the mass of an object increases, the acceleration decreases. Mass is inversely proportional to acceleration. When the mass is constant, if the amount of applied force increases, the acceleration of an object also increases. Force is directly proportional to acceleration. Second law of motion states that the acceleration of an object is directly proportional to the magnitude of the net force acting on it and is inversely proportional to its mass. That's the end of our lesson. I hope you learned a lot from this video. Do you have any comments, clarifications, or additional information? Feel free to ask your teacher. For online learning, open your Google Classroom or Facebook group page and click the link posted by your teacher. For modular learning, get your printed module and open the post test on page. Write your answer in the answer sheet provided.